You know, we might be standing right on the edge of a brand new frontier in AI. I want you to imagine for a second an intelligence that's truly inspired by nature. One that doesn't just, learn from a static data set, but one that actually adapts, grows, and can even heal itself in ways that our current models just can't.
I mean, really think about that. Instead of building this rigid, pre-designed machine, what if we could spark an intelligence that organizes itself? One that literally weaves its own structure together as it learns and experiences the world. This isn't some far-off science fiction concept. It's the real idea behind the new approach we're going to dive into today.
Okay, so before we can really appreciate where we're going, we've got to get a handle on where we are right now. Deep learning has done some absolutely incredible things, for sure, but it's built on a foundation that's starting to show some pretty fundamental cracks.
Think about your typical AI model, like a pyramid. You feed all your data in at the bottom, right? It gets processed layer by layer going up, and then an answer pops out at the top. But here's the catch, and it's a big one. Once you start training that model, the pyramid structure is basically set in stone. It's fixed.
And this is where you really see the problem. Living systems, like us, we're dynamic, we adapt. But traditional AI, it's brittle. If you try to teach it a new trick, it often completely forgets the old one. It's a real thing called catastrophic forgetting, and it's just as bad as it sounds. The system can't heal or adapt on its own. It has to be completely retrained from the ground up. It's basically hit a rigid wall.
So if our current model is too rigid, where do we look for a better one? Well, why not look at the most complex, most adaptable systems we know of, the ones all around us in nature? And it turns out the secret ingredient is self-organization. This idea is everything. In nature, you see this incredible global intelligence that just emerges from a bunch of very simple local interactions. There's no big boss, no master architect telling every little piece what to do. The system organizes itself.
A perfect example? An ant colony. Seriously, no single ant has the master plan for finding food. Each ant just follows a dead simple rule: follow the strongest chemical trail. But because the shorter paths back to the nest get reinforced faster, a super efficient, globally optimal network just appears out of all these simple decisions. That emergent intelligence is exactly what we want to harness.
And that is exactly what brings us to synergistic deep learning. It's a fascinating attempt to build an AI based on these very principles. We're talking about a system that can, in essence, weave itself into existence.
Now, to get this, you kind of have to flip your thinking on its head. Instead of just pushing passive data through a fixed network, this model uses something called information entities. You should think of them less like data points and more like active agents. Each one is a little learner with its own memory, its own state, and the ability to reach out and connect with others.
Yeah, each one is almost like its own little mini brain. It has its own evolving understanding of its world, it keeps a memory of what it's done before, and crucially, it can send messages to its neighbors. This active, agent-based approach is what gives the whole system its power.
So, instead of that rigid pyramid we talked about, you get this, a dynamic, living web. The connections between these entities aren't programmed in. Nope. They form, they get stronger, or they fade away based on how well two entities are working together, on their synergy. The network is literally building and rebuilding itself constantly, in real time. So what does a crazy new architecture like this actually unlock? Well, it takes a direct shot at all those weaknesses of traditional AI, creating a system that is just far more flexible and resilient. So here's what a healthy synergistic network looks like when it's up and running. Each one of those nodes is an information entity, and all those lines between them are connections that are strong because they're working well together. They have high synergy. The whole system is humming along like a cohesive, intelligent unit.
But watch this. Look what happens when a part of that network fails. Let's say a sensor goes offline. The connections that relied on that node, they just weaken and die off. But almost instantly, new connections form to bypass the damage. The system literally heals itself. It reroutes the flow of information on the fly with no human jumping in and no need for a total reboot.
So the advantages here are pretty clear, right? It can learn new things its entire life without that catastrophic forgetting problem. It's incredibly robust, like we just saw. And, this is really interesting, it can actually be easier to interpret. Because entities that work well together cluster together, you can start to see how the AI is thinking. You might see a cluster form around all the entities related to identifying a person. Face detection, voice audio, keywords, all grouping up naturally. But of course, this kind of power comes with some pretty big challenges. A self-organizing system is, by its very nature, way more complex and a lot harder to control. Constantly calculating all that synergy between entities takes a ton of computing power. And even though those clusters can help us understand it, the network is always changing, which can also make it a black box that's hard to predict. There's a real risk of instability if you're not careful.
So what this research does is open up a completely different future for AI, one where it's less like a brittle tool we use and maybe more like a resilient, living partner we work with. And the potential applications? They're transformative. I mean, just imagine it. Fleets of drones that organize their own search patterns after a disaster. Medical systems that can weave together scans, lab results, and a doctor's notes into a single holistic diagnosis. Or recommender systems that can perfectly balance what you want to see with hard safety rules. These are the kinds of messy, dynamic problems this AI is built for.
And that, of course, brings us to the final and maybe most important question. When we create an intelligence that can grow and change and organize itself without our direct command, we're building something with a kind of autonomy we've never seen before. So the challenge for us isn't just a technical one, it's philosophical. How do we make sure an intelligence that thinks for itself stays aligned with our own goals? That's the big question this leaves us with.